This lesson goes through the percentage techniques most likely to appear in a numerical reasoning paper. Some of it will be familiar. Pay attention to the parts that look obvious. The most common errors live there. The word percent is short for per hundred. A percentage is just a fraction with 100 locked into the denominator. 30% is 30 over 100. 45% is 45 over 100. The trick to fluency is to do the conversion the moment you see the symbol. So the percentage stops being a percentage and becomes the fraction or the decimal you can actually compute with. Going back the other way is the same logic. 40% rewrites as 40 over 100. Reduce. 40 and 100 share a factor of 20, and you get 2 over 5. Same number, 3 different costumes. To turn a fraction into a percentage, multiply it by 100. 2/5 times 100 is 40%. 3/8 times 100 is 37.5%. Percentages are often easier than fractions when you are comparing things. 23 over 31 versus 17 over 24 is intimidating. 74% versus 71% is a glance. The fastest way to compare fractions with different denominators is to convert both to percentages and read off the larger one. A student scores 27 out of 30 in maths and 42 out of 50 in geography. Converting. Maths is 90%. Geography is 84%. Maths is the higher score. The mechanical work is 2 divisions. The cognitive saving is that you no longer have to think about a common denominator. Whenever a question gives you a part and a total and asks for the share, divide the part by the total and multiply by 100. 36 shares out of 300 is 12 hundredths, which is 12%. Half the skill is reading the question well enough to identify which number is the part and which is the total. A percentage question is often dressed in the language of proportions, rates, or shares. If the question contains the phrase out of every 100 or out of every 1,000, it is almost always a percentage question in disguise. The under 25 complaint rate is 4.2%. Per 1,000 adults, that means 42 adults complained. Either compute by decimal, 0.042 times 1,000, or scale by 10. 4.2 per 100 is 42 per 1,000. Same number, 2 roots. The diagnostic is verbal, not numerical. When you spot any of those keywords, mentally substitute percentage, and the question solves itself. To take a percentage of a quantity, multiply the quantity by the decimal form of the percentage. 25% of 80 pairs is 0.25 times 80, which is 20 pairs. If your tester allows a calculator, the decimal form is usually faster. If not, the fraction form is often kinder to mental arithmetic. 25% is 1/4. Quarter of 80 is 20. Either way, you arrive at the same place. A percentage greater than 100% is allowed and behaves exactly like any other percentage. The same multiplication formula applies. 135% of 80 is 1.35 times 80, which is 108. Numerical reasoning sometimes uses percentages over 100 to express growth. For example, sales. This quarter are 130% of sales last quarter, meaning sales have grown by 30%. Reading the question precisely is the only skill that matters. Percentage change has 2 formulas, one for rises and one for falls. They differ only by sign convention. In both, divide the size of the change by the original value, then multiply by 100. A coffee shop raises an espresso from €1.60 to €2. The change is 40 cents on a base of €1.60. 40 over 160 is 1/4, so 25%. Per capita mortality from a particular illness falls from 19.5 to 16.2. The change is 3.3 on a base of 19.5. That works out to about 16.9%. A useful shortcut for increases. The new value divided by the old value, minus 1, is the same as the percentage increase divided by 100. 2 over 1.6 is 1.25. Subtract 1, 25%. Notice the denominator is always the old value, not the new one. Dividing by the new value will give you a similar looking but different number. Always anchor on the starting point. Successive percentage changes compound. You cannot add the percentages, you have to multiply the multipliers. Year 1 revenue is 48 million euros. A 12% rise gives year 2 of 53.76 million. An 8% rise on top of that gives year 3 of 58.06 million. The wrong way is to add the percentages. 12 plus 8 is 20, and apply 20% to year 1. That gives 57.6 million, which is short of the right answer. The reason: the second rise is applied to a base that has already grown. 8% of 53.76 is more than 8% of 48. Always multiply the multipliers, never add the percentages. For any percentage change, the multiplier is 1 plus the percentage as a decimal, with the sign matching the direction. A 1% rise is multiplied by 1.01. A 25% fall is multiplied by 0.75. A doubling, 100% rise, is multiplied by 2. Memorize the multipliers for the round percentages. They turn arithmetic into a single multiplication, and they make successive changes effortless. Reverse percentage questions reverse the direction of the calculation. You are given the final value and asked for the original. For a discount, the final value is 100% minus the discount, as a fraction of the original. A jacket sells for 36 euros after a 20% reduction. That 36 is 80% of the original. Divide. 36 over 0.80 is 45 euros. For a markup, the same logic in the other direction. A printer sells for 322 after a 15% markup. That 322 is 115% of cost. Divide. 322 over 1.15 is 280. The mistake to avoid: do not apply 20% to the final price and add it back. 20% of 36 is 7.2. 36 plus 7.2 is 43.2. Wrong. The percentage was taken off the original, not the final, so you must divide by the multiplier, not add the percentage to the final. This last point is the most punishing of the lot because it looks like wordplay until it costs you a question. A percentage point is the absolute difference between two percentages. A percentage is a multiplicative ratio. They are different things. A local authority recycles 18% of its waste this year. If the target is to increase the recycling rate by 5 percentage points, the new rate is 23%. Just add. If instead the target is to increase the rate by 5%, the new rate is 18.9%. 18 times 1.05. The word points is the signal. Whenever you see it, add or subtract. Whenever it is absent, multiply. That covers the techniques. 2 final reminders. Always anchor a change calculation on the original value, not the new one. And the distinction between percentage points and percentages is exam gold. It shows up in a small number of questions, and it is almost always set up to catch you. Practice each pattern until the right multiplier appears in your head without effort. The arithmetic in a percentage question is easy. The question reading is everything. Here is the reference. The simple average is total value divided by the number of items. Rearranging gives you the total or the count from any two of the 3 quantities. Memorize these. Most numerical average problems reduce to one of these forms.